Hey everybody, today we are going to see very interesting problems here. So we have a set of interesting things to look at, including optimization problem, an example taken as paraboloid what you are seeing now, and we're gonna solve it by using a new Python library called optunity, and we are currently visualizing it using Plotly. So I'm going to show you how to write your function in Python and how to visualize it using Plotly, and then how to optimize the function, either finding the minimum point or maximum point by using the library called optunity. Okay, let's get started. So we have optimization problem. So what is optimization? Optimization problem consists of maximizing or minimizing a real function by systematically choosing input values from within an allowed set and computing the value of the function. Okay, so if you see here, so these are the allowed set of values. Input range x and y is a function, and this is the value what we are computing. If you see, I started from here, x and y are 10, so the value of z is minus 173. So if I'm going upwards, the x and y values are going to the center like 3, 2, 1. As I'm reaching to the top, so the z value is changing. See, so this is what I'm talking about. Okay, this is a real function, and in a low range of input, okay, x and y, we are finding the value of z, and here we want to find the maximum value. Okay, according to the Wikipedia, so this is max paraboloid function. So this looks like this, and this what you're seeing under here is called contours. Okay, this is the point we are interested in. This is the point where this function get maximized within this range. Okay, so this is what we have plotted using Plotly. Okay, I'll show you how to do that. Before that, we'll get to know what we are going to achieve. So the paraboloid is given by the function z, which is minus x square plus y square plus 4. Okay, so the global maximum for this function is at 0, 0, 4. That means when x is equal 0 and y is equal 0, the value of the function f of x comma y is gonna be 4. So this is indicated here as a blue dot. Okay, so this is what we are going to get. Okay, how we are going to do that? So we are using this optunity library. So this is a library containing various optimizers for hyperparameter tuning. So you can find the maximum values or minimum values, and you have a bunch of other options as well. So you can find a lot of other examples here and already solved notebooks, so you can explore this library. If you want to install this, you can simply use pip command to install. Pip install opportunity will do the job. Let's go to the problem and let's see how we write the function and how we can do optimization. Okay, first of all, I want you to import all the required packages. So the main functions here are the numpys, Plotly. So Plotly has these two. Okay, Plotly has py and Plotly graph objects as go. And as usual, we just imported numpy and IPython's image function to display this image. Okay, so I took the image URL and I'm displaying here. So this is what our aim is, to find the maximum value. Okay, and now, so this is our function f of x comma y is equals to minus x squared plus y squared plus 4. So it can be implemented using Python within a single line of code. So define the paraboloid using x and y as this. So this is that simple. Okay, so you can write some doc string to explain it. You can make it as a very good function, but for simplification, so I just used one liner. Okay, and so we are using the range of -10 to 10. You can change this to -5 to 5 or whatever as given here. So here they have used a -3 to 3 and -3 to 3. Okay, so you can change it, and so the linspace function will give 240 points between -10 and 10, as usually for here for t also -10 to 10, 240 points. So we are getting mesh grid out of it, so we'll get mesh grid for s and t both, and we are putting them into x and y so that we'll get so this grid and this grid, and we are gonna compute z as a function paraboloid. Okay, so this takes x and y and computes z. Okay, now our first task is done. So we have initialized the value, so the range of values are given and we computed the function. Now our task is to find the optimum value. So we want to maximize function. We want to find the values of x and y where the function get the maximum value. Okay, so before that, I would like to visualize this function. So visualization gives more intuitions. We understand the problem very well when we visualize it. Here comes the plotly for the rescue. So we are defining a function. So this is uh, a surface plot. We are going to plot it as a surface plot. So we are taking x, y, z values and plotting the surface using the graph of objects of plotly. Okay, so the data is given here. We are plotting this kind of, so this is the plot what we are going to get. For this we are defining a layout. Okay, so for x-axis, y-axis, z-axis, we want some grid color, so zero line color, show background whether true or false, and background color. These are some parameters we need to pass as a layout so that we'll get this kind of layout. You can tweak these values to get different layout. Okay, so this is the layout section here, and so this is the data. Now so we are initializing a figure, and by using plotly we are displaying the figure with the file name. Okay, so this is a function. Now what we are passing is, for the function plot 3D func, we are passing x, y, z values and file name as paraboloid. Okay, so the paraboloid function is plotted as this. You can see these values as you are moving the cursor over it. If you don't want to see, you can change it here so that you just only see the curves without the values. And if you can rotate it, you can see the highest point. Okay, and you can rotate to the bottom, and if you want to get back to the original view, you can click here to get it back. And you can also zoom it and zoom down, and you can also rotate and rotate only in the vertical direction. So you can do a lot of things with plotly. Actually, that's a beautiful feature of plotly. I just liked it. Okay, so now we have defined the function and we have computed the function f of x comma y and z values. Okay. And we defined a function to visualize it, and we visualize it with the xyz values as paraboloid here. Now it's time to optimize the function. So here comes the optunity. So we just imported optunity by this line, and now you have multiple options here. You can maximize a function or minimize a function. So and you can pass in the paraboloid function here. This is a function name, and this is number of evaluations, how many times you want to evaluate the function within this given range. So the given range of x comma y values are from -5 to 5 and -5 to 5. Okay, so that it will compute the optimal parameters and details. Okay, so we are very much interested in optimal parameters. So those are the values of x comma y where the function get maxima value. So if you run this, you'll get these values, and if you put the values into the paraboloid function, you will get this value. So here, if you see here, this 3.99 is almost equals to 4. Okay, so that is what our target is. That is what we are trying to achieve, is at the point 0 0, this function gets 4 as the maximum value. Okay, this is a numerical precision. That's why we get some value after 0 and some value after 0 and some value near to 4. Okay, so this is how you can define your functions, you can visualize them, and you can find the optimum point, either the maximum or the minimum. Okay, so you can change these parameters, you can run more number of evaluations, and if you want to do more optimization problems, you can go to this website. I'll provide this in the description below. So this has a lot of different functions. You can take them and you can do the same as we did and find the minimum or maximum, just optimization. Okay, thank you guys. If you like this video, please do like and subscribe and share with your friends.